For this problem, you're going to get to use some of the further momentum knowledge that you've learned. You're going to get to see how momentum problems play out in higher dimensions. So here, imagine there's two ice skaters, and one ice skater is heading due west at 10 meters per second, and he weighs 50 kilograms. The other ice skater is heading at 14 meters per second to the west, and 14 meters per second to the north. They're going diagonally. And they weigh only 30 kilograms. So try to calculate what their x and y velocities will be after the collision. Remember, because the ice is smooth, we're assuming there's no friction. So as a result, it's just a momentum problem. So take a second together. Okay, so let's go through this together. First of all, we need to find the total momentum at the beginning of the problem. So we'll do it component by component. The momentum in the x direction, which will represent as p sub x, equals 50 kilograms times 10 meters per second, or 500, plus 30 kilograms and 14 meters per second, which is going to the left, so we're going to call that negative. So that's going to be minus 420. So that's a grand total of 80. And we're not going to worry about units here. The units are long and messy. They're kilograms, meters per second. So you wrote that out, great. If not, we just need to remember that's a unit of momentum, and as a result, only gets added to other momentum units. Now let's do p sub y. This time, the first ice skater has no y component to his momentum. So we're just going to look at the momentum of the second skater. That's 14 meters per second times 30 kilograms, and that equals 420. So now that we have the original momentum, now we need to do the final momentum. And the final momentum is just going to be their combined mass, 80 kilograms, times some velocity, and that still has to equal the original. So the final in the x direction, p sub f sub x, equals 80 kilograms times v sub x, velocity in the x direction, and that has to equal 80, the same as last time. So now we get to just divide through by 80, and that's really easy. So velocity is 1 meter per second. P sub f sub y equals 80 kilograms times v sub x, and it equals negative 420. Sorry, positive 420. And once again, we divide through by 80, and we end up with 420 over 80, which boils down to 5.25. So as a result, because that's positive, they're going 1 meters per second to the right, and 5.25 meters per second north. So their total velocity is going to look something like that. And that makes a lot of sense. So when we look back at the problem, the smaller skater has a higher velocity, and they're going upwards and to the left. But the larger skater cancels out a lot of the leftwards velocity, leaving just the upwards component of the velocity. So we look back, and numerically, we have a very small right-hand component and a relatively big upwards component. But the big component's still less than the speed. It's actually less than half the speed, because the smaller ice skater made up less than half the mass. So this checks out, this makes sense. So we can realize we did the problem right, and we successfully solved one problem in 2 dimensions. So using the same process, find the original, find the final, and solve for velocity, you can solve almost any momentum-related problem. So congratulations.